Okay, good morning. Today we're going to work on experiment number 3. Now, if you recall, we just covered forces in lectures in class, okay? And laboratory 3 is going to deal with adding forces. Now, the first thing that you're going to want to look at, and you're going to want to go back and review, is forces are vectors. And that's what this experiment today is going to demonstrate. You're not going to prove anything. You're going to demonstrate. But I want to start with the first concept, okay? And the first thing says Newton's law, second law, is F equals ma. All right, everybody knows that by now. But we're going to look at weight equals mass times gravity. Okay, now this is a question in the lab, and you're going to have to explain it. Why can I use a mass interchangeably with weight, which is a force? Okay, you got to answer that question. I'll give you a hint. There's only one constant here, so it's related by a constant. Okay, so now let's get rid of that. So here's what you have to do on this lab. This is maybe the most simple lab we're going to have. So the first thing I'm going to do is draw a circle. That is our tabletop. Okay. Now we're going to put two vectors in. We're going to load, there's a little bullseye right here. I'll make that. We're going to load a vector which is going to have a mass. We'll call that vector A and mass A. Okay. Then we're going to add another vector to it. We'll call that vector B and mass B. Now, if this circle in the center of the table can move, right now you would guess without a whole lot of error that this thing's probably going to move generally in that direction, depending upon the magnitude of these masses. The whole experiment is to take a third mass and figure out what the angle is and the value of the mass so that mass C, vector C, the sum of these add up to 0. Because remember the requirement for equilibrium, which is, I'll let you think for a second, that the sum of the forces got to equal 0. Okay, so we want vector C, vector B, and vector A to all add up to 0 to keep this bullseye centered, little spot right there, in that table. That's the gist of the experiment. Now, let's do one other thing here before we go any further. We're going to break A and C into components. So A, which is the blue vector, should have an X component that looks like that. We'll call that A of X. And it should have a Y component that looks like that. We'll call that A of Y. Okay, remember, we're dealing in 2 dimensions. So then we've got the B component, which should look something like this. And we'll call that B of X. And then we've got a Y component, which I'll have to skip around that capital B, and this is B of Y. Now, because this is the total vector, I could also write it as the sum of the forces in the X direction equals 0, and the sum of the forces in the Y direction equals 0. Okay? So, I ought to be able to say BY, AY plus CY equals 0. I should be able to say AX plus BX plus CX equals 0. That's the mathematical model. So the data is what you get when you lay the string out on the table and you move it around to get the right angle and you change the weights a little bit. Data. Mathematical model right here. That's the 2 parts of the experiment. So that's about all I'm going to say. We'll stop it right now and we'll actually show you one setup. Okay. Right there. Okay, now I'm going to show you one thing to begin with on this table before we go any further. First thing I want to do is set each of these little strings 120 degrees out. Okay, why do I want to do that? Well, if the weights on the end are the same weight, say 120, 0, and 240. Okay, you can see the bullseye sitting in the middle. I'm going to move it on purpose just to show you, but you can see this thing slides around a little bit. And there's a black circle with a black circle with then a black, it's actually a through, it goes all the way through, but there's a hole there. And this little disc, they call it the fisheye. The fisheye moves around depending upon how well this balances. Excuse me. So if these are set at 120 degrees and they have equal masses on each end, it should center. I had it centered and I just moved the table. Okay. So let's see. There's the 0, there's the 120, and there's the 240. Okay. And you can see by eyeball, it's pretty close to dead center there. And so that's how we center this thing. Now, I'm not going to do a whole lot of setups because in the write-up, I gave you some pictures to look at. So what I want to show you here is, here's a weight set. I'll hold the weight. So, oh, you got it. Okay. So all we're going to do is on the end of one of these, we're going to insert a weight. There's a couple weights. And there are some requirements for what you have to set for the weights. So this happens to be a 50-gram weight right there. And then we'll have 2 of them set. That's the A and the B vector. Then we'll have to move the C around to try and figure out how to pull this thing back. So if I just arbitrarily, without a whole lot of thought going into this thing, I'm going to put some weights on these controls right here, on these balances. There's one, and there's a couple. Okay, so you can see that the bull is pulled way off center. So now the trick would be to go figure out, and here's the problem. This is trial and error, because if I get the angle right, but I don't have any weights on it yet, I have no idea whether it's going to come back to center. Okay, you can see I just threw a couple weights on here, and it didn't come back to center yet. So either I don't have enough weight, or my angle is wrong. So now I got to move it around. And I'm betting that the angle is what's wrong, or the weights are what's wrong. The angle is probably somewhere in between. So now I just added some more weight to it. And notice it pulled it off to the side. So whoops, I'm off the runner here. Okay, so now you notice as I change the angle, it's starting to come back on. Okay, so it's close, but it looks like I got to add some more weight to it. So I'll throw a couple more on. And we're off just a little bit. There. Okay, so I've done that. That's how we do this experiment. And that's about all there is to it. And I'm going to quit right here. I can't see